So we've already done quite a bit of work with square roots, so this should be nothing too new. So first of all, let's just take a look at the parent function. So if I've got y equals the square root of x, how we're going to go about graphing this first one is by just making a table. So I've got my x and y values. Remember, for your inputs, your x values, you can really pick anything that you would like. So I'm just going to go with 0, -1, -4, 1, 4, 9, 16. I'm just picking some perfect squares here. Okay, so let's start with 0. So if I substitute 0 in for x, the square root of 0 is just 0. And I'm actually going to do the positive direction first. The square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. 16 is 4. And then my negative direction. So remember, if I have the square root of -1, that's just going to give me I. And if I have the square root of -4, we can work that out here. First of all, I'm going to have to simplify an I. So I've got I equals the square root of 4. The square root of 4 is just 2. So that's going to give me 2I. So when graphing, whenever you have imaginary numbers as your output, that's something we can't graph on a coordinate plane like this. So we're actually going to start graphing at 0, 0. I'm going to graph 1, 1, 4, 2, 9, 3, so on and so forth. And I'm going to have a graph that looks something like this. This is the graph of a square root. So for domain and range, my domain is going to be 0 to infinity, right? Since I can't have negative values because those are imaginary, you could also write this as x is greater than 0. And for my range, the lowest possible y value I can have is 0. And it's heading up, so infinity is going to be my max. Once again, I could write this as y is greater than 0. So let's go ahead and list a couple of our transformations. So my first transformation, you guys will notice these are very similar to some of the other types of graph we looked at this year. So my first transformation here that I notice, obviously y and x are just givens, they're in the parent function, but I have a. Okay, a is going to tell me my vertical stretch. And that would be if the the absolute value of a is greater than 1. So if a is greater than 1, it's going to stretch my graph. Or it'll have a vertical compression. And that's in the case where the absolute value of a is less than 1. Okay, the only other thing that a does is it will reflect over the x-axis if a is negative. Okay, so a determines a lot about our function. H, we've already gone over this before with some of our other graphs. H is going to be our horizontal shift. Okay, and K is going to be our vertical shift. Okay, so A really determines a lot of our different behaviors of our square root. H and K just really determine the starting point. So let's go over just a few examples down below. So for each of the functions, we are going to describe the transformations, create a table, and then graph. Once we're done with all of that, we are going to find the x and y intercepts. Okay, so first of all, let's look at our transformations. So let's just go down the list. First of all, I have an a value. Okay, my a value is 2. So this is going to cause a vertical stretch. And then I'm going to be more specific and say by a factor of 2. Next off, I see that I have an h value of positive 5, which remember your h value moves the opposite of what it shows you. So this is going to shift left 5 units. Okay, those are my transformations. So let's create our x and y values. You guys can choose whatever ones of these you would like, but I'm going to try to choose some nice ones. So I'm going to choose -5, -4, -1. I can make this a little bigger, actually. The -5, -4, -1, 4, 11, and 20. And once again, it does not matter which points you use. Use whatever inputs you want to. So -5, -5 plus 5 gives me 0. 0 times anything is 0. So -5 and 0. -4 is going to give me the square root of 1 times 2, which just gives me 2. -1, -1 plus 5 gives me gives me positive 4. The square root of 4 is 2. 2 times 2 gives me 4. 4 plus 5 gives me 9. The square root of 9 is 3. 2 times 3 is 6. 11, square root of 16. 4. 4 times 2 is 8. And 20. 5 times 2 gives me 10. So I know I went through that table solving process super quickly. Feel free, make sure you guys take your time. So I'm going to go ahead and graph all these points. -5 and 0. -4 and 2. 1 and 4. 6. And then 11 is going to be off my graph. But this is enough points to give us a good idea of how this is going to generally look. Okay. Next, we need to determine the domain and range. So the domain is all of my possible x values. My furthest value to the left that I can have is going to be right here at -5. And as I head to the right, I keep heading forever. So that's going to give me infinity. My range, on the other hand, the lowest value I can have is going to be 0. And the highest value is just infinity. Okay, you can also write this as inequalities as well. Does not matter to me. Finally, we've got the x and y intercepts. So my x-intercept is going to be right here at this point, -5 and 0. And my y-intercept, it's going to fall somewhere in between. So for your y-intercept, you are actually just going to want to plug 0 in for x. So if I plug 0 in for x, 0 plus 5 is 0. So that just gives me 2 square roots of 5. And there we go. That is everything I was hoping to solve for there. Okay, so I think this gives us a very nice start onto the lesson and should give you guys an idea of how to get started on these. Um, we are going to go through a couple more of these on the back side, but I think we're going to save those for class just because they are a long process. And I think it's best that you guys are asking some questions and participating along with solving these. All right. Thank you guys for watching. Make sure you bring any questions you have to class.